Yeah, yeah. Basically, agenda for today is as follows. We will present you and introduce you what we mean by STIF-ware and what are the concepts behind it. We're going to present you with the first generation of STIF, which had to fulfill the following goals. We had to automate, integrate, and unify the data exchange and integrate all of the tools together. Then we're going to run a demo for the first version of the STIF. After that, we will explain to you what were the problems that we faced when we were developing STIF, and then why are we moving to the STIF 2, which is like a next generation. And then we're gonna talk more about STIF prototype. After the presentation, we'll give this T-shirt that was being given to us by Hack in the Box crew, but we have basically a bit modified it by hand.
It's modified version, like a stencil on the top, and an industry slave, because it's the ideology behind the STIF thing. And we will award it to the
best question, yeah.
bringer.
Yeah, the best questions gets the T-shirt. Let's get going.
So basically, to introduce a bit what is the STIF framework, you can see that STIF is like a shortcut for STIF tool integration framework. And basically, the main purpose of the STIF is to have heterogeneous, like various tools to be unified in a single environment, so you can use them from a single spot basically, and to automate as much as possible execution and like all the routing work which has to be done in order to succeed in a network penetration thing.
Well, in simple words, it's basically a platform for automated hacking, whereas we have integrated using our inference engine all of the tools where you only have to issue one command, say add a target to the system, and the whole inference based on the rules, the inference engine will deduct what tools needs to be run based on the output of previous tools.
Yeah, basically we consider the tool to be like completely legal, so it's just up to you what you're gonna use it for. So we don't consider hacking to be illegal, but we consider illegal hacking to be illegal. So that's the thing.
Yeah. Why do we need automation in the first place? First of all, we need to have a machine-based knowledge processing. That is where we can outsource in some way these repetitive tasks to the machine, so that our brain could be freed for some more creative things. Like, as I said, yeah, one of other ways to use automated tools is basically create intrusion scenarios where you could either stress test or do evaluation testing of different network intrusion detection systems using the scripted out scenarios. Another reason for that is to mitigate the human error which can occur due to imperfections of our
Yeah, if you
brain.
do like certain tasks repeatedly, you can test like one thing once, but if you have to test like 100 times, there are chances that like one of like dozen things you're gonna miss.
Yeah, and ultimately we want to reduce human labor involvement in the modern penetration testing sweatshops.
And that's what the T-shirt is about as well.
Yeah.
Basically, why we need the integrations thing. The situation right now is that we have a large number like of the security tools which exist, but there is no way how you can like hook them together. There were some attempts to do this stuff like in a small scale, such as Metasploit framework. It's like a very good tool which gets all the exploits together. But still, if you want to automate the whole process, if you want to do like scanning, network sweeping, network mapping, and then like automate it, like exploiting all from the single box or like from the single system, there's nothing existent on the moment which can do it for you, roughly. Well, I think there is core like the product by Chorus, which is basically like a set of Python scripts which supposed to help you to do like penetration testing thing, but it's not really automated and it's not really free. Another thing that we want to be able to collect all the data and like convert it into format which we can store in database, so we can do like machine-based processing, like data mining and stuff. Because for a single network, it's cool, like you can like manage it by hand, but when you have like an A-class segment, there is no way how you can like go through all the text files and like analyze them like effectively.
That's a typical scenario that takes place now with security analysts maybe not using all those fancy scanners that give you these templated reports, but actually does the whole process by hand, which is a lot more, which brings a lot more quality in it. The way it works is the analyst first analyzes the results of the output of the tool, or if it's like a first time, he analyzes the target that he has and feeds that into security tools, and then analyzes again the output, and then based on that makes the decisions.
Yeah, basically, just to like note, we're trying to avoid the word hacker throughout the presentation because of the media created image, so we'll use the word security analyst or like security professional for the thing.
So yeah, if you want to see what happened to the Joe, the analyst, after 1 month of these repetitive tasks, yeah, poor Joe.
Yeah, he turns into monkey.
So why don't we let the machine do the boring part, where we, as I said, outsource all these repetitive tasks to machine?
Yeah, there are actually like other ways how you can solve this problem. Like one of the things which we used to do before, we used to write scripts. Like for every task, I would like script it out, and I ended up like with a bunch of scripts. I think it was over 1,000 scripts laying all over my hard drive. You can use the security scanners to a certain degree, but scanner is just a scanner thing. You can use like for certain like particular tasks, you can use exploit toolkits and things like that, or you can like hire a room of pen testing monkeys and like ask them to do the thing.
So one question that you should have by now. So what's the difference between scanners and STIF? I mean, it looks like it's the same thing where we have integrated all the tools. Well, there are several problems with scanners that we have today. First of all, is a hard-coded sequence of execution. All of the scanners today follow this pattern of the penetration tests, where they gather information, analyze it, perform vulnerability research, and then try to exploit the vulnerability and then escalate the privileges.
In fact, scanner doesn't really do like penetration tests for you. What it does, does like certain stages of like network gathering, and to the most that would be it just does like scanning, and then it does like port mapping, like.
Yeah, well, it depends on what kind of scanner we were talking about here. But yeah, the second problem is vendor-specific integration. That is, to integrate different tools into these currently existing scanners, you need to follow some specific API or some specific language like NASL. You need to follow some plugin APIs, which require code rewriting and basically hacking of the code of tools. And the last thing is that each vendor currently represents all of the data in their own format. If you see now, all the tools, most of the tools now actually provide you with XML output. But the problem is there is no use for that XML output, since you have to write the parsers for it, since every tool actually represents it in its own format. So it's not that useful.
There's no way to actually have like some sort of unified processing of the data, because there are so many like various forms. Yeah, and at this point we thought, why we just wouldn't write one? Like we'll write a framework which will like help us to unify the data, have like some sort of like common format to represent the data. I have some common framework where you can just plug the tools in and you can like let them run and collaborate together. So make the STIF.
First generation of STIF provides several features. First of all, it's a highly customizable rule-based inference engine, which enables a security analyst to script out any scenario based on the data that was returned by tools. That is, we have created a framework and then created the different converters for different tools that actually convert all the data into unified format, and you can actually operate with that unified format to script out scenarios of execution. That is, you can say, if you see port HTTP and, for example, IIS running there, you could launch some exploit based on that. Later on during demonstrations, we're going to show you how the rules looks like and how it all works. Secondly, it provides unified data exchange and representation format. That is, we have a set of XML messages that actually enable you to represent most of the data returned by currently existing security tools. Then we have a generic database publishing module, which could be quite useful for anyone who has their own custom database scheme and then they want to import the data from tools into into their database. Using our generic data, import the data from the tools into a database of any scheme. And also we have a data publishing and importing interface, which was implemented again as one of these things. We did it in IRC, so that means that you can actually connect several STIF agents, basically STIF nodes, through IRC, and they would collaborate and exchange the data over the IRC and perform the
Yeah, you basically
automated
connect
hacking.
them to the single channel, and on the different nodes, they can actually talk to each other through the channel by exchanging the STIF messages.
Next is the distributed architecture. As we said, employing the IRC, you can actually have several nodes, several operating systems running, different operating systems with different tools on them. And if you write all the rules properly, all of them will be working together to achieve, to basically to execute all of the tools in the sequence that was given by you based on the output of all of the tools. We have a ready-to-use database schema. At the moment, STIF, the first generation STIF was written in Java. The reason for that was because it was really quick to develop things in Java with all the multi-threading in there, and again, cross-platform capability.
And the other thing which we are trying to solve is data like representation unification. And in the first version, like the first generation of STIF, we developed an XML format which we call STIF message, which basically encapsulates all types of data that is relevant to the network mapping and like network intrusion thing. So we have XML format for like handling like host users, ports, URLs, user IDs, users, passwords, vulnerabilities, stuff like this. In the second generation, we'll move to it later, we actually expand it a little bit.
So this is a simple STIF message. As you can see, this one was taken from the output of Nmap. So what it tells you is that there is an open TCP port number 80 on the IP address 192.168.1.1 that has HTTP protocol running there with application of Apache 1.3.27 with PHP.
Yeah, and basically what happens like in sense of information, in sense of like data flow within the STIF, the information within the STIF is stored in format of the STIF messages. Whenever a tool has to be executed, the data is being converted from the STIF message into the format which the tool can understand by the tool execution tool wrapper module. The tool is being executed, and then the execution model is actually parsing out the tool output and converting the format back into the STIF format and injecting it into the STIF knowledge base.
Our inference engine. Well, inference engine that we have created is responsible for data exchange between various tools. That is, each tool basically injects the STIF message into the inference engine. An inference engine, based on the rules that analyst has created, will make a decision on what tool to run next and what arguments to give to the tool. Again, we will show you the rules later, so as soon as you see the rules, it will be a lot more clearer for you how it works. But basically, inference engine is the one that's responsible for deciding what tools to run and what input to give to these tools from the STIF messages.
Yeah.
Inference engine operates only with STIF messages.
Yeah, the inference engine is actually the media which takes the messages from one tool, reroutes it, and like sends it to the other tool. And the inference engine, like, it's equipped with a rule base which tells the inference engine what sort of messages should be routed to what sort of tool. And we also have a data publishing facility. We have a unified data publishing interface, and we have like two implementations right now. One of them is a database publishing interface, and one of them is the IRC publishing interface. But if you're really interested, you can actually hack one of your own. We only have that interface, so as long as you implement the interface methods, then you can have like a publishing interface of your own. And
yeah, this SQL publisher, that's what I was talking about, where you can actually save the data, save the output of different tools into your database. So this below shows you the sample entry in the configuration of SQL publisher. As you can see, for the message type of target, that is whenever you give IP address to be inputted into the system, the following query will be run with %h being substituted by the IP address of the host. And the same, for example, for the port, the thing, if you have, for example, a table where you need to actually link with a foreign key, where you have to link the ID to the IP address, and then the same thing, and insert that ID into the port table. Here we have basically first a select query, which selects ID field, which you refer in the next query by the $1 sign. And then NPS, port number, protocol, application level protocol, and then application version. So as you can see, this way you can actually import the data into any database of any schema.
You can basically integrate the STIF into your existing database, and that's what the database publisher is for. Yeah. Aside from database publisher, we also have IRC importer, which takes the data from the IRC channel and injects it into this particular node of the STIF installation. And we also have the IRC publisher, where you can define what sort of data you need to publish on the IRC channel, so like other people and other STIF nodes which are connected to the same IRC channel can see this data and import it into their knowledge base. And for the IRC importer and publisher, you should be able to see it during the demo.
No, we don't have IRC installed here, no, net.
Sites.
So yeah, sorry, no, but you'll see, yeah. So how your favorite tools integration, how can you integrate basically your favorite tool into STIF? So there are several ways to do that. First of all is you can use generic to STIF converter, which can convert basically any output of any tool using regular expressions into the STIF format, and that's what we use now. We have ported converted this way the output from the Nmap, from Nikto, from Hydra, and then and the Xprop. Yeah, that would be it. So basically using the regular expressions, we'll show you a sample for the Nmap. You can actually convert any output into the STIF format that can be injected into inference engine and used and digested by our inference engine. And another thing you could write is you could write a tool-specific wrapper that would again parse the output, and then present the inference engine with the STIF message in XML. Or of course you can basically hack the code and port it to STIF, which would be good. So that's a simple configuration for the parser. It's kind of complex, but basically what it says is that it gives you regular expressions to extract different types of data from the output, and then data into specific fields of the STIF message. And that's how it works.
Yeah, and basically, Midar just mentioned the tool wrappers. We actually have the interface for the tool wrapper as well. So all you have to do, you don't have to actually change the code at all. You have to implement your own classes, and you have to implement the interface that implements the methods which are required by the interface. And as soon as you do it, for the rest of the thing, you can just plug your tool in and have it running. And what else you can do to assist the development of the first generation of STIF? You can just download and try it, or you can, if you code any tools, you can try to port them to be able to generate the STIF messages as the output. So if the tool generates the STIF messages as the output, no data parser is needed. You can just plug the tool in and have it running in the exec model. And if any data parsing is required, you can write your own regular expression rules using generic to STIF converter. And the way you write the regular expression, there is just XML file, which is a configuration file, and you just put the regular expressions there. Or yeah, you can do the tool patching and stuff as well. And also, we're moving for the moment, we're moving to the second generation of STIF, which is sort of similar by design to the first version, but it has a few add-ons, and we'll introduce in a moment. Yeah,
and now we will demonstrate you the first generation of STIF. As you've seen, that we had that small video running here. Maybe now, after you've got the idea of what we were talking about, it would make sense more. So let me just run it once again.
Без музыки давай.
Без музыки никак.
Давай.
Basically, here we have several tools, and then the security analyst controlling them manually. So first, Nmap tries to hack the computer, but basically scans it. Then the second tool would be xproc, which after it has some ports open, it could actually tell you what operating system is running. And then here comes Nikto, and Nikto knocks out xproc now. So yeah, the error occurred and it fell down. So yeah, so now analyst, after seeing that he's not efficient enough, calls STIF. So STIF comes, he's really cool.
He integrates all the code.
Yeah, and he basically takes control of all of them and lines them all up. Yeah. Yeah. Hope you all liked it.
No, that wasn't a demo, that was just...
Hey, that wasn't a demo. We're gonna have a real demo now. So here I have started the STIF. It gives you several information messages, and what I do is I add, can you see?
Yeah. Фон побольше сделай. More visible, or can you maybe make it like bold or something?
Is this one? Okay, let me just надо было попробовать. Okay.
So basically you can see the output of the STIF loading log when it loads all the like models and stuff and loads the rules and things.
Yeah, so what we do now is basically we add the target to the system by doing add target.
Yeah, the way you communicate with the STIF, you have like command line, or you can implement your own interface. We implement the command line thing, and you just give the commands to STIF, and then it tries to match it to the rule base and sees which models can execute the command.
Yeah, so we add the target, and then we will see a lot of messages. We'll go through all of them now. But basically what happens is based on the rules that are outlined here.
Basically, right now, the way the STIF is implemented is it's an event-driven execution flow. So what happens, you give it like a new target. So it detects the event of like appearance of new type of information, and then it tries to find which tools require this information to execute. Once it matches like nmap and xproc, like both of them, they just need like a target. So it executes both tools. And the tools, once they execute, they generate a new type of input data, which generates like new events, like open ports, operating system type and stuff. And then, according to the rule base, the inference engine will try to match additional tools until no new events appear.
So yeah, so what do we see here is that first of all, xprob is executed, then we have nmap is executed. We'll show you later after that that in rules, it was all these two tools were registered for the message of STIF message of type target. So after that executed, nmap then feeds a new fact, several new facts into our system, which one of them states that there is a AT port open with protocol HTTP. And we have in our rules configured to run Nikto for that. So after that, after nmap is finished, as you can see here, Nikto is being executed because it has matched this rule that HTTP protocol is open on port 80, and that's output gets converted into and passed to the tool in the form of command line options. So after the Nikto has executed, it will return several URLs that it found. And this way you can actually, for example, if you find some, for example, I don't know if Nikto checks for PHPBB, but for example, if Nikto detected PHPBB, you could put into the parser your exploit for these latest vulnerabilities in the view topic and easily exploit them just automatically using through the rules engine basically. And all these rules, and this way it can go like forever if you have all the rules configured. So let's see now how actually the rules look like.
Basically, we also have like integration of like several like proxy servers. So in the intrusion environment, what you do, you just like browse the target website, and the proxy plugin, it actually generates the STIF event messages with the URLs as soon as it finds the URLs which the system might be interested in, like the active execution content, like CGIs, GSP, stuff like this. and then it will trigger the execution flows within the STIF. So all you do is just like browse the website, and STIF automatically runs all the tools for you, depending on what kind of tool would match what the type of data which it sees.
Yeah, so here we have first rule name scan, which what it means is there are two parts to the rule, which is a condition and then the action. So what we have is that we have a target, as you can see here. If the target message is given and it matches the following regular expression, which matches everything, then the following tools would be executed: xprop and mam seed version, and then the message will be logged. So after these tools have executed, we have another rule called web scan, which what it does is it matches the port message. As you can see here, as long as the state is open and the protocol is TCP, we don't care. We don't care about the number since it matches everything, and we care about any address. And as long as the protocol is HTTP or HTTPS, the following two tools will be executed, which is nikto, verbose, and then HTTP brute. As you can see, these are just basically short names for the tools, and the way all the command line switches are actually defined in another file called exec.xml.
Yeah, there's just like nicknames for the types of execution, and you can call them whatever you can, because there are like 100 or like 1,000 ways to execute nmap, and there's like a number of ways how you can execute nikto. So you can just define different execution like methods, and then you can refer to them through these nicknames.
So I don't know if you can see this blue.
Может цвет поменять? Да. Yeah, probably more visible this way. Basically, that's how you can convert the STIF messages into the format which the tool understands. We have several conventions that whenever you use one of these characters, it will be replaced with the host, protocol, port, user ID, password, and all the other data from the STIF message.
Basically, it's pretty simple. You have %h for host, %p for protocol, %n, and then down there, for each of the tools, as you can see here, what we do is that we execute nmap and we pass parameter %h, which will be substituted for the IP address of the host. And then for nikto, we have %n, which would stand for port number that HTTP protocol has been found on, and %h for the host.
Yeah, the same thing with Hydra and like all the other stuff.
Yeah, so basically you can, as you can see, after adding your tool to exec.xml, you can put the rule here in rules.xml that would run your tool based on the conditions that it needs to meet first. Yeah, well that's about it about demo. If anyone has any questions, or
yeah, for basically for the
demo.
first generation of STIF, that's basically it. And we'll, if there are any questions, yeah, what the question is? Well, basically what you can do here, we have a database publisher. So what you can do, you can push the data into database, and then you can generate your reports using any database tools, or you can even write a PHP script which will just take the data from the tables and generate the report. For the moment, we have we were experimenting with a PHP interface for the reporting, but we're not releasing it because it's still very rough.
Yeah, see, the STIF is more of an inference engine, which basically digests the information and provides you with publishing modules which you can use to do anything. You can save the data, you can save all the STIF XML messages, and then write your own parser to actually parse the data and generate a report. Additionally, in the logs directory, you have all of the logs of all the outputs of tools. So that means that, for example, if STIF missed something due to some bug, the whole thing is not really wasted and not lost, because you still have logs of the output and you can always review them manually.
Yeah, basically if you need to confirm any data with any data that is found in database and you want to find where it came from, because not all the tools are error prone, you can just go into the log folder and you can see the log of all the tools which were executed.
Yeah, so this is just the run of the nmap that we just had now. So you can see the output. It's still available for you to use. But yeah, I mean, If you want to write a report, the easiest way would be to use a generic database publishing module and to actually import it into your database and generate report from there.
Yeah, are there like any other questions regarding the first version of STIF?
Or maybe the demo
Or maybe the demo or... Well, if there are like no questions, then we move to like, okay, what the question is? Coffee, yeah, if you can write a plugin to make coffee, well, basically once we we've done the system and we like use it in real life applications, we found out like a few limitations that we had in design. So right now we're working on a second generation of STIF to resolve the issues. And one of the few issues which we found was with the current implementation of STIF is one is the complexity. Right now the inference engine, we think if you want to add new stuff into that, the inference engine is already quite complex. And when you integrate these things, it's just a big piece of code which can be easily broken and you have to basically find dependencies and things when you put the new stuff in. So we're thinking of actually do a bit of decoupling. We want to separate the inference engine and the execution models and everything into different parts, which we'll show in the next slide. The other thing is, even though STIF knows they can communicate to each other through the IRC, it was actually quite interesting thing to play with when we can see different nodes to be able to talk to each other. But the thing which we realized is that it's still, there's no facility exists which we can use to distribute the actual attack among different nodes. It's just they share the common information, they have their own execution rules, but there is no control where you can say, yeah, I want this node to run the scanner, and then I want this node to run the HTTP scanner, or I want to run this node and this node, both of them I want them to generate the scanning results and then compare it to find out the firewall rules. And another thing is, even though the inference engine is quite smart, and it still does a bit of a dynamic thing and try to find the matching rules, but it's still just driven, and it's the rules are hard-coded. There is no way, if you find out one of the rules doesn't work, you cannot just kill one model and replace the rule and let the model run again. You have to shut down the whole system and then start it up again. And we felt it was a bit of limitation, so we want to resolve that as well. And also for the knowledge interchange format thing. Right now, the STIF format, it only represents the network layout thing and the things which are related to the IP network. But what we have realized, aside from the IP network, it's also good to especially during the information gathering phase, you also want to find out what people exist within the target network or target organization. You want to find the links between them. You also want to find the branches and how they link between each other, and then link it to the IP network. So we felt the original STIF format had this limitation, so we are working on extending that as well.
Yeah, well, regarding the functionality decoupling, right now we have this big piece of code which contains all of this. Yeah, inference engine, knowledge base, publisher, importer, and console. What we want to move to is we want to move to a multi-agent architecture where you would have each of these subsystems as an independent agent, which could be run either over the network or maybe locally on the host, which would give you the ability to actually unplug each part of the system, unplug each agent at any given time, and then plug it back in.
And tune it separately. Yeah, but basically the current diagram of the STIF is this big square. So you can see all the components are still part of the single program. Yeah, and basically we had a few other targets which we want to achieve in a second generation of STIF. One is we wanted to make platform independent, which means not only a mobile platform which you can do with Java, but we also want it to be a language independent. And the way we want to address this is by introducing the messaging framework. So what we'll have to do is to port this messaging. Well, one of the things is a common protocol, basically. The common protocol is just the protocol which the STIF agents can talk over the network. So it's not like a single process right now when you have to use certain API to be able to like edit your own tool. All you have to do is to be able to follow like certain protocols, so you can code either the protocol thing, or you can use our like framework in whatever language you like. And then right now, like the second generation of STIF is composed of agents. They're like completely independent agents. They can be run on the same box, or they can run on different like systems. They can even run on different networks, and all you have to do is to tell them how to communicate to each other. And the only thing which they need to know is the main node, the node which carries the naming service, which we'll talk about a bit later. Yeah, and the other thing which they have to follow the messaging protocol which we are designing. Right now we're using the FIPA protocol, which is like soon to be standard protocol for like agent communication, but we feel it doesn't really fit into our needs, so we want to develop like our own extension of the thing. Yeah, and one of the key things in the second version of Snort, initially we only had this event-driven like execution flow when you see a certain type of data and you want to execute the thing. But sometimes you don't have like any input data, but you want to give like a goal to the agent or a goal to the system. Like, yeah, I want to compromise this network, and then you want the system to run until it actually achieves the goal. So what we have is a capability thing where each tool or each like a tool wrapper which can wrap a single tool or like multiple tools is assigned like a number of capabilities. Capabilities is basically what the tool can do, and then we have a matching system which will like do the capability matching, and we'll introduce like in more detail like on next slide. Yeah, so the second version of STIF has like architecture which will look roughly like this. Right now we have implemented the naming service. For the message exchange framework, right now we use a standard package which implements the FIPA message exchanging, but we want to replace it with our implementation. And we have tool wrappers where like you just have like an nmap daemon which will just like sit on the system and listen for the connections. And then whenever you need like once the tool is started, it has to register itself with information lookup service where it registers the capabilities which the tool can do. For example, if it's an nmap daemon, it can do like scanning, it can do TCP scan, it can do UDP scanning, it can do like sweep. All these capabilities you like pick them up yourself. The only thing is within the STIF framework there should be some agreement. So when certain tool registers the capabilities, the other tools should know if they need like to implement the scan, they have to look for the like scan capable like agents. And we also have interest list, which is also supposed to be registered within the information lookup service. The interest list is a type of data which the tool is interested, or the type of data which the tool can take as an input, so it can start the execution. In the first version of the tool, that was the STIF message which should be matched in order to trigger the execution of certain tool. And in the second version, we moved to the point so it actually becomes an interest. So when the event generates with a certain type of data, each agent should look up for the agents which are interested in this sort of data and pass the data to the agent. Yeah, and we also have like the console agent. In the first version, it was just interface. Right now, the console agent is just a separate agent. And for the user interface, all you have to do is like to implement your own program and follow the protocol to talk to the STIF system.
Message exchange framework, we wanted to make it abstract. That is, we will not be really bound to for example, TCP or UDP. The whole message exchange framework would be implemented in such a way that it could be, for example, implemented as a plain TCP connection, UDP. It could be done over ICMP. We were also thinking about doing this through also through instant messaging. And another thing that we are thinking of doing is using stenography. And additionally, we wanted to implement the SMTP and POP3 communication. That is, you send all the messages and all the exchange is taking place over the SMTP and
So
retrieved to a POP3.
yeah, so basically when two agents they're using like the the message exchange framework, the communication with the message exchange framework is transparent and it's just the API. Of course you can implement your own protocol, but then you have to also like follow up with all these covert channels which might be in use. By default, right now we're just using like a plain HTTP connection. It's it's, it's basically two agents that you talk to each other using HTTP, but you can also encapsulate this into other like protocols, so you can create like covert channels and tunneling. And this stuff is absolutely transparent to the agent. The only thing agent needs to do is to look up for the name of the other agent, to talk to the naming service, and use the API to send and receive the messages. Everything else is transparent.
The goal-driven execution is that it's like a term taken from multi-agents. Basically, the idea is that each agent will describe its functionality with a set of capabilities. That is, what that tool can actually do, what this agent can do, and on what type of objects it can do the following actions. And then each agent is given a task to execute that particular capability on that particular object, and then this becomes agent goals, and the agent will now, using all of its capabilities, have to try to achieve the goal. And that's the idea behind the multi-agent architecture of STIF2.
Yeah, and basically each agent, it also maintains like a library of plans how it can achieve like certain goal. For example, if you need to penetrate a network, there are, I think would be a number of ways what you can do, like what sort of activity you can initiate to penetrate the network. You can like do the sweep scan first, or you can do just like scans on port 80s, or you can do like a regular scan. And agent, it will have like a plan of a library of plans, and it should like pick up one plan, and it will try to execute it. If the plan fails, it maintains the plan execution succession rate. So it will try the other plan, and this plan will like have 1 minus. So next time when it needs to pick up the first plan, it will pick up the plan which was successful the most of the times. And this way we can have the execution flow, which is not fixed to like a particular hard-coded execution scheme that we had in the first version of STIF. So each time the execution happens, we have certain degree of randomness, but within the scenarios which are described by the security analysts. And also, the other things which can affect the plan selection, not all penetrations can be like direct, straight. So we have implemented certain environment settings in a system. So right now it's just a latency, like which means which states like how long this plan would take to be executed. And if the requirement of the current environment is to have the plan to be executed as fast as possible, the plans which have like shorter like latency time will be executed. And we also have like stealthness. If the plan is like to run a very noisy scan, maybe the agent will pick up the other plan for this particular like scanning attack.
And we're also going to have, besides that, event-driven execution flow. That is, each agent may be subscribed to different interests. That is, it can express its interest in certain types of data that it should receive, it should be subscribed to. And as soon as this type of data arrives, the agent will be notified, and this event will be delivered to the agent. And whenever the agent discovers new data, the interest list is queried for all of the agents that are actually interested in the data, and then the agent would be responsible for actually forwarding the data to all the interested peers.
Yeah, as you saw the diagram, there was like information lookup servers. So all the queries for the interest, when agent starts, it should register its own interest in that system. registrar capabilities as well. And whenever new data appears, the agent looks who is interested in this sort of data and just forwards the data to the agent. So this way, we almost, well, we don't have like so much centralization in the system, except for this information lookup service. And this also can be designed like on peer-to-peer scheme, but it's a bit more complex, so we don't do it in the moment.
Yeah, and each agent will maintain its own local cache of all of the knowledge it queried for, which would be called its data cache, or could be called its beliefs. And each agent will be able to query other knowledge bases, other agents for other keybase of other agents for the missing data. That means that the whole knowledge will be somewhat distributed among all of the agents, and you not
particular data regarding the host that does not exist in a local agent like knowledge base. It can query the agent knowledge base within the agent network and see if the data exists within that knowledge base agent. So basically right now within the like API and the protocol we have implemented the feature, and the way you implement the knowledge base it could be up to you. It could be just like a plain database, or could be another system just which maintains the data regarding the target network. And if it has the data, it can respond with the data. If it doesn't have the data, it can respond with just refuse the response message.
Yeah, we currently have implemented the prototype for the whole thing. It's still in Java using Jade framework. The communication protocol is still rather simple and in progress. We did that more of like a proof of concept prototype. The knowledge base, the knowledge interchange now, we're basically reviewing it. We were thinking of using either KIF or DAML, but we're still researching into that. And once we finalize the communication framework, we will replace the currently used Jade framework using our own, which would be with all these abstract things for the message exchange.
Yeah, right now basically the reason why we're using Java is just to get a feeling of the messaging communication, because a few things which we like discovered, like potential problems, we only saw them after we actually tried a few agents to talk to each other. So once we ensure that the protocol which we want to use is like more or less final version, we want to get rid of the Jade framework and want to have like a simplified version, because Jade is actually a large large framework for scientific research, and a lot of features that Jade has we don't really need them. All we need is just like a message exchange layer. And for the information exchange, we're extending the STIF right now, and we're looking into two like current standards for knowledge representation. One of them is KF, one of them is DAML. We're extending the STIF right now, and we're looking into two like current standards for knowledge representation. One of them is KF, one of them is DAML. DAML is like some sort of like DARPA-sponsored research on knowledge exchange, and we're seeing if we can like integrate part of their like ideology into the STIF, so we would be able to wrap a larger amount of different like data objects within our message exchange framework. Yeah, and as Medar said just now, like once we're done with the finalization of the protocol, then we'll just get rid of the Jade and we'll publish the protocol spec, and we'll publish the framework, like our own implementation of the framework thing.
So yeah, everyone who is sleeping, wake up now.
We don't do the demo for the second thing, because it's just like an output of like messaging things between different agents. But after the conference, we'll put the code on the website so you can download and try it for yourself. Yeah.
So.
Well, in the first engine, whenever it finds more than one rule to be matched, it will like choose one rule. In the first implementation, we had like just if it has like 3 rules, it just choose one randomly. But in the second implementation, what we have like the matching rule, we call it like a plan. So it will maintain the succession of the plan execution like as a score, and also a plan might or might not have like certain environment settings, like how stealthy the plan is. So it will pick up the plan which is like has the highest succession rate. But I think we still should have a bit of randomness there because for different networks, like different plans might succeed. So I think in the current implementation, it's just like a random selection on the second thing as well. But we want it to be like affected by the succession rank.
No, I think now, well, I don't think I'm sure now. In the first STIF, if you have, for example, several rules matching, actually several entries matching the one, all the tools are executed in parallel in separate thread. So it should be, it's just shown here, but I mean, how big is the network that you want to scan? Like scalability in what sense? In the number of nodes or? I think most of the things here would be basically limitations of your operating system. Basically, whatever the JVM imposes onto the. But at the moment, I don't know.
Yeah,
we
basically,
did not run
for the second version, we expected there would be like certain scalability problems. That's why we wanted to be like distributed. So different agents you can install.
Onto the. But at the moment, I don't know.
Yeah,
we
basically,
did not run
for the second version, we expected there would be like certain scalability problems. That's why we wanted to be like distributed. So different agents, you can install them on like completely separate systems. The only thing which depends on how many agents you have is the naming service. So more capabilities you have, more resources that machine has to have. Because when it does the lookups, if you have like probably over 100 agents with different capabilities, that might be a bit slow. But otherwise, like in the second implementation, the system is like completely distributed. So it should be quite scalable, I think. But we didn't do any testing.
Yet. Any other questions?
Any other question? Yeah.
What would stop you from sending rules to, say, other nodes to create something like a denial of service attack or something else?
Well, we have like authentication credentials. So when you install the agents, it's actually me who decides which agents I allow to talk to each other. So there are like no malicious agents, unless you compromise the system which has the agent installed, and you can steal the like credentials from that agent, and you can like do your own agent which will try to like de-risk my system. But for the moment, we don't have any like mechanism to detect this thing because it's still a prototype. But we might like work on it later.
Yeah, sure. Yeah, botnet.
You mean the botnet, like the IRC bots thing, which? In which way you think it can be like more effective?
Yeah, well,
Yeah.
well, first of all, the STIF is implemented in Java, so you'd have to make sure that all of your bots have actually Java. But it would depend on C. The STIF itself is just a framework for exchange of data, and you can actually integrate any tools into the framework, be it some DOS tools or anything. Basically, the STIF itself, what it does is it converts the data into STIF message format, digests it, and based on the rules, executes some commands. That means that, for example, in your case, you could use it, and you could actually script out different things in STIF also, and to create botnets, which is bad anyway.
Basically, for the second version of STIF, if you want like STIF to integrate into botnet, you can actually write an agent, which will be like a botnet agent, and you can allow the agent to talk to STIF messaging system. So whatever you command through the botnet can actually be like proxy to the STIF system, and whenever your agent gets any data from the STIF system, it can like send it back to the botnet. You can just integrate two systems together. The only thing which you have to create, like in order to integrate like second version of STIF with whatever like framework you have or whatever like system you have to write an agent which will be able to talk the protocol which second version of STIF understands.
But if we talk about efficiency, it all depends on in what way efficient you want it to be. For example, in terms of memory use, you know, it's Java. It will be a lot more than probably the regular bots. But other than that, it should be pretty efficient. But it all depends on what you use it for.
Yeah, as far as I know, like botnet, it just like sort of automated like tool execution, but it doesn't do any like information exchange between the the different bots, and that's the difference probably, like which differs botnet from STIF. So if you want to integrate this like STIF functionality into botnet, you might want to do like the botnet agent for the STIF thing.
Any more questions?
Did we actually answer your question, or?
Yeah, no, I just feel that it's quite effective if it's implemented in a bot.
Well, it's kind of like an agent is actually a bot, or a bot is actually an agent. The only thing, we don't use IRC to talk, but if you want to use IRC to communicate, you just
Yeah.
How secure is your program?
in what sense?
Well, if somebody will try to create a separate tool which will try to abuse your, well, I saw some like injections, right? I mean, I saw some serial communication with database, right? So if somebody will try to write their own tool, so the STIF will try to execute and will pick up the output and will, based on this output, it will inject some data in your database, something like this.
Well, first of all, as the STIF is actually escapes all the data before putting it into the database, so it fixes the SQL injections. But the other thing you're talking about executing some binary that it does not know, it really depends on administrator. If you have this tool configured in your rules, that I mean, you hack yourself. Simple like that. Any other questions?
Any other questions? Any other comments?
Suggestions?
Drink offers. Что? Думал, музыку можно. Да. Нет. Давай попробуем. Просто тот мужик, который...
Yeah, we're just deciding on the...
We're thinking who actually wants the t-shirt?
Yeah, the multi-threading questions, yeah, there were several questions from there, so you get the shirt.
Yeah, we get a lot of questions from this area, so we decided to award you with a t-shirt. Hey! Yeah, the t-shirt like this is like only one in the world. Custom made.
What do you use to create the video?
To create what?
Video.
It's actually
3D Max.
my friends in one small company back in Kyrgyzstan, they use 3D Max for that. They have been rendering it for 1 week, I think. And it's still not finished.
Did we answer your question? All right, then we consider the presentation to be over, and thank you very much.